Okay, AP Calculus AB, finding the derivative of logarithmic, exponential, and transcendental functions. This is logarithmic, so this isn't this, Joel, g of x is equal to 2 ln of x? So there's two ways you could do this, isn't there? Right, you could do this, you could go back and look at this as if this was a power rule. So you could do this way. Let's see if it works out the same. You do it this way. You could say that this is, that g prime at x will have to equal 1 over f of x, right? Times what? Yeah, times g prime at x times the derivative of the inside piece, right? Will give us 2x over x squared equals 2 over x. And all I'm saying to you is, if we use the rules of the properties of exponents, we can do this another way also, right? We can use this rule here that we can take this exponent and roll this back as a coefficient. That's what I did here, right? If I did that when I take g prime at x, I get constant multiple of 2 times the first derivative of ln of x, which is 1 over x, isn't it? Which is equal to 2 over x. Same answer?
Does it matter what the variable is? Like if it were ln of y, would it just be 1 over y?
Yeah, it doesn't matter what. Y is a kind of a weird question to ask because we start asking if we have implicit differentiation going on. But it doesn't matter what the derivative is. As a matter of fact, this rule is written this way, right? The rule is often written d dx of ln of f of x. But some texts will write d dx of ln of u. And all they're saying here is that if they're saying f of x, they're saying it's not, the function is not ln of x. It's ln of 2x, ln of x squared, ln of something different. Is that all right? Great question. Let's go on. So here's our second question. Am I allowed to roll this thing forward? Take a look at this question and this one and see how they're different. Here we're taking the quantity ln of x to the fourth power. So we have ln of x times ln of x times ln of x times ln of x, don't we? Want to see that? And if you want to break it out that way, you could certainly do that. I'm not sure that I would. But here I'm going to use what? Yeah, I'm going to use the chain rule here. I'm going to take the derivative of the outside function and the derivative of the the derivative of the outside function. And remember, we're talking about the outside function. We're talking about this function right here. So I take the derivative of that outside function, which is 4, right, to the third power. That's all I'm doing here, Joel. You're right. I'm just taking the derivative of the outside function, right? I leave the inside function the way it was. The inside function the way it was, times the derivative of the inside. And what's the first derivative of ln of x? 1 over x. So here we have 4 ln of x cubed all over. This is kind of important because when you're taking the multiple choice part of the AP exam, they're gonna try to get you this way. So remember, this is not ln of x to the fourth power. It's ln of x, quantity to the fourth power. You see the difference, Elsa? Really important. Let's do one more. Here, I'm going to use properties of logarithmic functions. I'm just going to rewrite this. I'm going to do a rewrite here. I'm going to rewrite this as ln of x plus 1/2. Sorry, 1/2 ln of x squared minus 1. Is that true? Where does 1/2 come from?
Square root.
Yeah, right, this square root right here. I just traded this square root in. Square root is the same as to the 1/2 power, right? Right, let this be a power, and I just rolled that thing forward using that property of exponents. I'm sorry, property of logarithms. Is that okay? Now this gets pretty clean, doesn't it? Going to find the derivative here. Y prime is going to use the sum and difference rule. First derivative of ln of x is 1 over x, isn't it? First derivative of this thing is plus 1/2 what? 1 over
x squared minus
exactly right, times
2x.
times 2x. This 2 and this 2 go to 1.
So it's 1 over x plus x over x squared minus 1.
Is that okay? This is 1 over x plus x times, whoops. Joel, do you want to do this? Is this what you want to do? that what you want to do?
Yes.
Good. I like that. Okay?
Is the 2x on the outside parentheses, is that a power? Or
No, this is not a power. That's a really good question. It's not a power. I'm sorry. I just brought it out. It's the derivative. That's a really good question, Ken. It's the derivative of this inside piece, isn't it?
Oh, okay.
Good. All good? Okay.